How about this one? Sounds the same, but there is just one hitch in this particular sum, which I would like to stress. A person is standing between two vertical cliffs. Again, the person is standing between those two vertical cliffs, 640 meter away from the nearest cliff. So he's at a distance of 640 meter from one of the cliff, and they are saying that that is the shortest distance. So definitely the other cliff is still farther apart. He hears the first echo after 4 seconds. He hears the first echo after 4 seconds, and the second echo 3 seconds later. Look at the word later. What does it indicate? The time required for the second echo? Time required for the second echo is going to be 4 plus 3, that is 7 seconds. That is where the hitch was. So when they use the word later, that means time required for the second echo is going to be the time for first echo plus the time for the second echo. So I have calculate the velocity of sound in air. At the same time, the distance between the cliff. Now that I have the time, I have the distance, it is very easy for me to calculate this. The distance is given as 640 meter for the shortest cliff. Time required is 4 seconds. So I can determine the velocity of sound in air. Velocity of sound is nothing but distance upon time. That is 1280 divided by 4. That is nothing but 320 meter per second. Second part of it, again, the second echo is heard from the farthest cliff. The time required is 7 seconds in this case. So I have velocity again, twice distance upon time. If I substitute, 320 is equal to twice distance upon 7 seconds now. Remember, students always make this mistake. It's saying 4 seconds later, or after 4 seconds with the first echo, we have 3 seconds, that is the time required extra for the second echo to be heard. So we have 320 is equal to twice distance upon 7. Calculating the distance, I get distance is equal to 1120 meter. They are not asking you the distance of the person from the second cliff. They are asking you the total distance between the two cliffs. The total distance between the two cliffs is nothing but 640 plus 1120, which is nothing but 1760 meter. That means the distance between two vertical cliffs is 1760 meter. So you see, with these variations of examples that I've come across in the boards, definitely this chapter from board point of view has a large weightage as far as the numericals are concerned. The weightage though on numericals, you do expect theory questions on the resonance, a very important phenomena which you cannot forget as far as sound is concerned. Phenomena of resonance, forced vibration, then musical sound and noise, quality timbre, pitch and shrillness, loudness and intensity, and then if not anything else but echo. So all this put together constitutes what can be expected in the board examination. In the board examination, the weightage for sound is approximately 10 marks, wherein you have 2 marks in section 1 and you have 8 marks in section 2. So let's consider this first one. It says, that was appeared in 2002, an observer stands at a distance of 850 meter. An observer stands at a distance of 850 meter from a cliff and then fires a gun. So he's firing a gun at a distance of 850 meter from the cliff. After what time gap will he hear the echo if sound travels at the speed of 350 meter per second? So they have given you the wave velocity, they have given you the distance, they are asking you to find out the time. How do we do it? For an echo to occur, our basic relation remains the same. It doesn't change at all, irrespective of the condition that has been applied. For an echo to occur, wave velocity is equal to twice distance upon time. If I substitute, I get 350 is equal to 2 multiplied by 850 divided by time. On calculating the time, I get the time equal to 4.85 seconds. So therefore, after a time gap of 4.85 seconds, the observer hears an echo. Simple. How about 2003? A bit of numerical that was based on, these amplitude and loudness. There's a correlation between amplitude, intensity. Intensity is directly proportional to square of amplitude. So this is a numerical based on that. The ratio of amplitudes is given as 4:9. There are two waves who have got their ratios of amplitude as 4:9. You're asked to find out the ratio of their intensities. As I said, the relation that we use here is intensity is directly proportional to square of amplitude. So if amplitudes are in the ratio 4:9, the intensities will be in the ratio of 4 square is to 9 square. That is 16:81. So the ratio of amplitudes is 16:81. Ratio of intensities is 16:81. Talking about the next sum that came across, a pendulum. Pendulum is a vibrating body, has a frequency of 8 vibrations per second. What does 8 vibration per second indicate? Number of vibrations performed by a vibrating particle in a vibrating medium in 1 second is called as frequency. 8 vibrations per second indicates the frequency of vibration of the pendulum. An observer starts the pendulum. So the observer gives the periodic force and starts the pendulum and fires the gun simultaneously. So he is firing the gun also at the same time when he starts the pendulum. He hears the echo from the cliff after 8 vibrations of the pendulum. If velocity of sound is 340 meter per second, if the velocity of sound is 340 meter per second, what is the distance between the cliff and observer? See, they have really merged 2 or 3 concepts together and have asked you this particular question. We say that the time required for 8 vibrations, which is equal to 1.6 seconds. We know for an echo to occur, wave velocity is equal to twice distance upon time. So 340 is equal to twice distance divided by 1.6. As a result, we get the distance is equal to 340 multiplied by 1.6 divided by 2 equal to 272 meter. So the distance between the cliff and observer is 272 meter. Let's consider this question that appeared in 2007 now. Again, based on echo, a radar is able to detect reflected waves from an enemy aeroplane. You must have seen during the war times, it is the radar that basically gives you the ins and outs about an aeroplane from the enemy. It's a detecting device. How do they detect? It's basically because of the sound wave that is striking it. After a time interval of 0.02 millisecond. See the accuracy that they have as far as detecting such aircrafts are concerned. If the velocity of wave is 3 into 10 to the power 8 meter per second, you're given the velocity of sound wave or the wave that is being given by the radar as 3 into 10 to the power 8 meter per second, you're asked to calculate the plane from the radar. How far is the plane from the radar? Answer: for the radar wave signal to reflect back. We are talking about the sound wave that is traveled over there and then reflecting back. So for the wave to reflect back, we have the common relation. Wave velocity is equal to twice distance upon time. So I have distance is equal to wave velocity multiplied by time divided by 2. If I substitute the value, I get wave velocity as 3 into 10 to the power 8 meter per second multiplied by 0.02. But now this is in millisecond. So I have the multiplying factor as multiplied by 10 to the power minus 3 divided by 2. On calculating, I get it equal to 3 kilometers. So I know that the distance of the plane from the radar is as low as 3 kilometers. How about the 2008 one? Again in 2008 we had a similar one wherein it's a radar that is sending a signal. A radar sends a signal to an aeroplane at a distance of 45 kilometers away. Now here the distance is given. So they are talking that the radar is sending a signal, a sound wave to an aeroplane that is at a distance of 45 kilometers away with the speed of 3 into 10 to the power 8 meter per second. After how long is the signal received back from the aeroplane? So now they are asking the time. So just a small twist and then the same question repeats. For an echo to occur, our relation remains unique. Wave velocity is twice distance upon time. If I substitute this, I get 3 into 10 to the power 8 is equal to 2 multiplied by 45 divided by t. On calculating, I get that the time required for the signal to come back is 3 into 10 to the power minus 7 second. So my answer is the signal is received back after 3 into 10 to the power minus 7 seconds. Let's see how we can memorize this entire chapter. Being an important chapter, definitely you need certain things as the basics that are needed for the examination. So how do we memorize it? There's a brain map that we give you across. First part that we study is the waves. What exactly is a wave? How are they classified? They're classified into two categories, mechanical and electromagnetic. When we say mechanical are the waves that are requiring a material medium for its propagation. Electromagnetic waves do not require a material medium for propagation. Example, very good example for mechanical wave is sound wave. And very good example for electromagnetic wave is light wave. And we know light travels through vacuum. So definitely it does not require a material medium. As far as mechanical waves are concerned, they are divided or classified into two types. One is transverse waveform, second is longitudinal waveform. Transverse waveform, we see that the vibrations of the particle are perpendicular to the direction of propagation of wave. We say such a waveform is called as transverse waveform. In case of longitudinal waveform, we see that the vibrations of particle are either parallel to or along the direction of propagation of wave. We say such waveforms are called as longitudinal waveforms. Then we went on to the concept of vibrations. Which are the different types of vibrations? We had 4 types of vibrations. One was free vibrations, second one was forced vibration, third one was damped vibrations, and fourth is sympathetic vibrations. Free vibrations, when an external periodic force is applied, the body continues to oscillate indefinitely with a constant amplitude. These, we said, are unrealistic or impractical, idealistic concept. Why? Because it requires a vacuum for its propagation. Second one that we considered were forced vibrations. That is, because of the influence of one, the first vibrating body influences or forces the second body to vibrate. When this type of vibration is performed, we see that it is forced vibration. The third one we considered were damped vibrations, which was a realistic case of free vibrations. When the external periodic force is applied on the body, we see that the body starts vibrating with reducing amplitude. This is because of the presence of external damping forces, which is caused by air resistance, and hence we say such type of vibrations are called as damped vibrations. And last was sympathetic vibrations, which is a special case of forced vibration. We say that it is nothing but resonance that occurs, and resonance occurs only when the frequency of vibrating body is either equal to or an integral multiple of the frequency of the vibrating body. We say sympathetic vibrations occur. We did consider a large number of applications in sympathetic vibrations. Like we had resonance in air column, resonance in straight string, resonance in musical instruments, soldiers crossing over a bridge, opera singer singing, and so on and so forth. Then we came to the concept of noise and musical sound. I gave you the example of a discotheque. I gave you the example of teacher and a student relationship. I also can give you another example about elections. You see, during elections or festivals, huge pandals are set across. You know, the person who is campaigning for himself is going to create a large amount of sound. He's going to be very vocal all throughout that campaign. Though after 5 years, he is not vocal at all. But still, during that campaign, he is vocal. During that time, the local residents definitely feel it to be a noise. But for him, it is musical sound because he is enjoying it. So anything that gives you pleasure is musical sound. Anything that irritates you is noise. Then we went on to the concept of echo. In concept of echo, we said the repetition of sound that is heard after striking a solid rigid obstacle that is kept at a minimum distance of 17 meters is called as echo. So we had the condition for echo as the minimum distance for an obstacle to be there is 17 meters. The sound should persist in a ear for 0.1 second, and the absorbing surface or the surface through which the sound is being reflected should be non-absorbing, should be rigid and dense.